Oh!
What? No way.
In college, I met a little friend called AliExpress, and when I learned how cheap you can buy servos, I bought a lot of them. No, I mean a lot of them. But the question now is, what should I do with them? A while back, I made a mini robot arm that could do very basic tasks. So I started there. I did all the inverse kinematics, designed and 3D printed, and then coded it to draw on a whiteboard, which is when I learned why they were so cheap. So instead of going back to the drawing board, I went away. If I have 24 servos, I could make 8 robot arms. So I thought, what is useful and what could I help to change the world? Or I could shove them all in a boat and make them row across a river. Now that I've proved that it can float with a battery, let's talk about that battery. It can provide 14.8 volts at 624 amps. To put that in perspective, that's a ton of amps. But the servos only run off about 5 to 6 volts. So I added some voltage converters that help drop the voltage from 14.8 volts down to the 5 volts that help power the servos and the Arduino. It's time to plug in the battery and hope that nothing blows up. The battery has voltage of 16.2, and our servos are receiving 6.18. That's huge. And now with the Arduino attached, 3, 2, 1. That's not awesome. That shaking is unfortunately due to a phenomenon that I do not give a shit about. So hopefully it doesn't get worse. Time to build the rest of the arms. Right now, the battery can slide around inside the boat, so I 3D printed a bracket that holds it in place. It uses the Lego studs to stay in the correct spot. After some wire management, the boat is looking real close to the finish line and also something that will never see the inside of an airport. I added a jumper to some solder pads to give each servo board their own address. I first coded all the arms to stand straight up, and somehow worked first try, and the boat was even waving at me. But you can't row a boat with all the paddles standing straight up in the air, so I need to make a rowing motion, or a gate. Instead of using all the gross inverse kinematics to make an optimal rowing path, I did what any good engineer would do. Brute force. Oh, good lord. G to start rowing. Fuck! It's doing something. 3, 2, 1. Okay. What is this? This is Jerry. He's so shaky. Jerry is shaking a lot more than before. I decided that I still don't give a shit and that the water would help dampen the oscillations once it's rowing. Oh! I need it faster. Okay, that's faster. For now, I've been controlling all the robot arms through serial commands through my PC, but in the water, I decided to use a button. But I was too lazy to find a button. I think it's ready to test. And by test, I mean throw it in my bathtub. Oh my gosh. I can feel pushing so hard. Wait, ready? It's so good. It's so good. Oh my gosh. It's time to take it to the river. A lot of blackberries. I think I made it. See water. It's been 5 days. Hey, that's what you're gonna be when you grow up. Oh, fuck. Get back here. Great. Now my hands are wet, just in time for me to plug in the battery. Awesome. There's water on a servo already. Fair me. All right. IP-1 waterproof this. As long as water doesn't get in the boat, I'm happy. It do go down. It do go down. Oh. Let's go. Okay, stop it. I need a better system. I should make this remote control. All right, don't go running away now. Let's see how far this guy gets. I might have to direct it a little bit. This could be a bad idea. Oh, my waves. It's working. Holy shit. Okay. So there's water. All right. Jerry and the crew might not have made it across the river this time, but I'm not done trying, so make sure to like and subscribe for part 2.